already worked example 5 in class, but I'm going to rework that, and then I'm going to work the next 3 examples for you so you'll have some examples to go back to work through your homework. So from the top of a lighthouse, an observer notices a boat. And finds the angle of depression to be 12 degrees. I think it's easier if you draw this and make your angle of depression your angle of elevation because they're equal. The boat is 900 feet from the bottom of the lighthouse. What is the height of the lighthouse? So you're doing opposite over adjacent. So this is going to be tan 12 equals opposite over adjacent. So your number is in the denominator, so you are multiplying. So you're doing 900 times tan 12. And right now we're rounding everything to the hundredth. So you should get 191.30 feet. Okay, let's go down to the next one. The angle of depression of a car from a hot air balloon basket is 40 degrees. Okay, so we have this triangle and we have this car here. I'm not very good at cars. I didn't go to art class in college, I guess. So this is going to be 40 degrees. The balloon is directly over a water tower that is 5 kilometers from the car. So this distance is 5 kilometers. Find the direct distance from the balloon to the car. So the direct distance means if I measured it, diagonally, here's the hot air balloon over here, what is that direct distance? So in this case, we're going to be doing adjacent over hypotenuse. This is going to be cosine equals adjacent over hypotenuse. When your variable is in the denominator, you're going to say x equals 5 over cosine 40. And you should get 6.52 kilometers is your direct distance. Now, the next two are going to be about an airplane. And I want to talk about the difference between flight distance and ground distance. So on number 7, it says a pilot is required to approach a runway at an angle of descent. Angle of descent is the same thing as angle of depression, measuring 20 degrees. If the altitude of the plane is 10,000 feet, what is the flight distance to the runway? So now would be a good time to pause the video, draw it out on your paper, and then come back and make sure that you're doing this correctly. So we've got this airplane up here. Again, I don't draw airplanes. And my angle of depression is 20 degrees. Altitude is my height, so it's how high off the ground it is. So this is 10,000 feet. And I want to know the flight distance to the runway. Now, when you're in an airplane and you are descending, you're not dropping straight out of the air. So your flight distance is going to be diagonal, okay? So that's going to be a hypotenuse. And so here we're going to have opposite over hypotenuse. So this is going to be sine 20 equals opposite over hypotenuse. So we're going to get 10,000 over sine 20. And so your flight distance is 29,238 feet. All right, again, I'd like for you to pause this video and read the problem, draw your picture, set it up, and then turn the video back on and make sure you're drawing these correctly. After flying at an altitude of 9 kilometers, an airplane starts to descend when its ground distance from the landing field is 175 kilometers. Now, the problem before this was our flight distance. Our flight distance is the distance the airplane is in the air. Our ground distance is how far is the airplane, so here's my airplane, to the runway, but on the ground. So my ground distance is here. And the altitude is 9 kilometers. And we want to know our angle of depression. All right, so we're doing opposite over adjacent. So we're doing tan theta equals opposite over adjacent. We're looking for an angle measure. So in your calculator, you're typing tan negative 1, 9 over 175. And remember, there's no equal sign that you're typing in. You're just typing in tan negative 1. I like to do control divide, 9 over 175. I keep forgetting I have to put a decimal place in here. You should not have to be putting a decimal. Okay, and so your angle of depression is 2.94 degrees. All right, so I would like for you to work through the practice problems that I posted, and then I'll answer questions in class tomorrow.